Okay, so let's look at this problem. This is the one that kind of scared me, right? Because I was like, crap, I don't know what these are. So I'm just going to have to guess. And really wasn't that great of an idea because let's look at the actual question they're asking. How long does it take for one of these particles to reach a sample? So what they're asking for is time, and to reach a sample, so you're starting at one spot and going to another. So they're asking how long, how many seconds it takes to cross a certain distance. Okay, well that sounds a lot like a kinematics problem. So I should be able to solve that kind of problem. Kinematics are fairly simple, right? I'm scared off because I don't know what an MEV is. But wait a minute, I don't have to know what an MEV is because let's look at what type of problem it is. Well, it's a cleverly disguised kinematics. What is an MEV? I don't know. I don't have to know, it tells me. 1 EV equals 1.6 times 10 to the negative 19 joules. Wait a minute. I know what a joule is. That's a unit of energy. And now I look, 1 EV equals this. Well, now this becomes just an SI prefix. So this is the mega prefix. I know what the mega prefix is. It means there's going to be a million of those. So I'm just going to have to alter this by 6, alter my exponent by 6, and I'm going to get what an MEV is from an EV. So let's see here. I wrote it down here. I do know what the prefix is. So I can say that 1, and this turns out to be an electron volt, but 1 mega electron volt must be equal to 1.6 times 10 to the negative 13. Because all I did was if I make that number larger, I'm going to have to make this one larger. So in this case, it's not about moving the decimal point. It's adding a prefix that's a larger prefix. So this is going to have to move down. So I move my decimal point 6 places. Now, I can work with joules. So we don't want to forget that we don't just have that. We have 2 of them. It says we have 2 mega electron volts. So I just went ahead and did multiplication. 1.6 multiply it by 2, you get 3.2. So now we know that our helium ions have 3.2 times 10 to the negative 13 joules of energy. This is super important. All right. Now, we know we're getting a kinematics equation, so we don't want to lose sight of things we need in kinematics. We're not going to be able to find time because that's what the question is asking for. We already have distance because it gives it to us. So our distance is 0.15 meters. Just make sure you convert. And so I either need to get velocity or acceleration. Nothing up there makes me think that I'm going to be able to get velocity or acceleration. Sorry. I don't see any changes happening over time. So I don't think that acceleration is going to be a good thing to look for. So let's look for the velocity. How could we get the velocity? How is velocity related to what we know, which is energy? Well, if something's moving, it's kinetic energy, right? And we know that there's a formula that ties those two together. So 1/2 mv squared equals the kinetic energy. All right, so let's take a look. If I do this math, and this is done by hand and just estimating, so I'm able to take the 1/2 mv squared. We know what the mass is, right? It tells us the mass as well. Up here it tells us that each of these is 4 AMUs, and it tells us how many kilograms 1 AMU is. So we just take this number, multiply it by 4, and I didn't even take that number. I did 1.7, multiplied it by 4, so I rounded. I got 6.8 times 10 to the negative 27th. So now I have mass, I have 1/2, I have the mass, and I have the kinetic energy from up above. So now all it is plug and chug. So, and what's interesting is when you round like that, you end up with these two numbers, put them over top of each other. Well, for MCAT, that's close enough to 1 for me. So, and especially since the answers that they give us have different orders of magnitude. So all I'm going to do is make that a 1. And that makes sense because now the square root of it's super easy. And then I get an even number. Awesome, because now when I do a square root, I know that I just have to add the exponents, and these are going to be single exponents. It's not going to give us something like a 7.5 exponent or something like it would if this was a 15. So now we have the velocity, which is 1 times 10 to the 7th meters per second. And I feel like I'm done, but I'm not, because remember, this is a kinematics problem. So now I can use the most simple formula that we know, which is distance equals rate times time. So now we have a distance, 0.15 meters. We have a rate, 1 times 10 to the 7th meters per second, and we're looking for time. So all I do is I'm going to switch that to be in scientific notation because that's what I always do. Then it's 1.5 over 1, simple. That goes away, it's just 1.5. And then for dividing these exponents, all I do is say, okay, I'm going to add that -1. I'm going to plus, and then since I'm moving this from the bottom to the top, it switches the sign. So -1 plus -7 is -8. 1.5 times 10 to the -8 seconds is the time that I think it would take. And in this case, I didn't have an idea at first, but now I do, and actually it is exactly that. Perfect.